Hello and welcome to my Nintendo Wii video 7 on 3D graphics. So in this video I will show you how you can load models and use those on the Wii using display lists. So let's get into it. So today's video I will introduce the Wavefront OBJ 3D format, which is the file format we will need to convert for a usable 3D format on the Wii. This is just a format that I'm happy using. Originally the image converter I created was just for converting 3D graphics to work on the Nintendo DS. However, I found that this the format that I was using was useful for everything, so I literally use it for everything now. I'll then go over what to do with the exported object data after we've converted them using display lists on the Nintendo Wii. I'll then show you how you can add models, and we will be using Blender for that, which is a free open source 3D modeler in case you are unaware. So first off, let's have a look at the demo. So what we have is a 3D scene here. We control a camera from the sidelines and we can spawn various actors to bimble around inside the arena. So if I press A, then we will spawn a new actor. They make a bouncing noise whenever they hit an obstacle. And we can also change the backgrounds as well. And then if you move down into the walls here, you can get an up close and personal view. So you can see changing the background there. So there's I think there's like 4 actual models for the actors here, with a couple of textures each. So I will leave it there for the demo there, so you can see what we're actually doing there. I will quickly show you the models in Blender. So here's our 3D cow. And then if I go into edit mode here, you can see that the cow is made of lots of triangles, which are all connected together to create our model. And then another key thing to note here is this little dot in the center of the cow. This is the center of rotation for the model. So another weird thing that you need to be aware of in Blender is the Y and the Z axis is the opposite way round. If you look up here, you'll see that the Z axis here is actually the vertical axis in Blender, and the Y axis is forward and back, which is not the case in any sort of 3D programming that we all do. And then we have a Gumba model here So these models I got from models resource, which I will go into in a bit, and I will show you how to pick a model, download it, and then import it to Blender, and more importantly, set it up so that we can import it for use by ourselves for whatever we wish. And then here's the monkey here. Did a few tweaks to this to make its tail curl. And then we have a shy guy here. I think most of these were from a Mario Party game. And then I created my own tree model here to use in the scene. As I didn't actually, I don't know where to look to try and find something which was low in polygons, but at the same time had like a cartoony sort of feel to fit in with everything else. And then here we have there's two types of walls. There is a horizontal wall. If I scale that, then you will see the details on it. And then we have a vertical one here as well. Just fix that rotation there. I'll explain that in a moment. So this is the vertical walls on this scene. These are the horizontal walls here. So you basically connect these next to each other to create the scene. However, when we export things, we need to make sure that the scale factor here for everything is 1. And that's so that the scaling is normalized. So the real dimensions here, but when you scale it out, these all need to be 1. So I will introduce the OBJ format, which we will be saving our models out of Blender in. So what we're looking at here, the OBJ file, the Wavefront, there's like a text format, which is what we're looking at here. The key things we are interested in are these lines with the V, the ones which start with VT, and the ones with VN. We also have an interest in these lines which start with F. So if I open up Blender again, and we'll side by side these a moment. So what you're looking at on the left hand side is this one here. If it was positioned like this. So what I've done there. So what we have here, this is the world cursor. Which is positioned at 0, X, Y, and Z. So you think of it as like a graph here, like. So we're looking at this plane here, which is a flat shape from directly above here. This is as if we are looking down on it from above. The camera is positioned directly above it. And then if I go into this mode here, and I triangulate these faces a moment, what we have is one triangle here. In fact, let's see better in this view here. We have two triangles here. And then if I go into vertex here, you can see the dots in each corner there, hopefully. So there's 4 vertex. So this vertex here would be at 0, 1, 0 on the Z plane. This one down here would be 0, 0, 0, which is, funnily enough, this one here in the text file here. So basically anything with a V on it in this text file represents a vertex and its position locally in the model space, if you like. So there's 4 vertex which make up a plane, and then in this case here, these ones with VT on it refer to the texture coordinate. And if we apply a non-scaled image onto this, which I will do now, so I'll select the material properties for this here. We'll add a new material, and then on base color here, this is how we add a new texture to an image, or a new texture to a model, sorry. And then we will select a texture. So in this case, I will select the grass texture floor, and there you go. The plane now has texture coordinates. So Blender has added the texture coordinates for us. If I open this up in UV editing mode, so texture coordinates, to adjust them, you would need to be in edit mode, and then you would select the faces that you wish to edit. On the right hand window here is the 3D model view, and on the left hand window here is the UV or texture coordinate view. So you'll see, if I select these 3 here, these are the corresponding UV coordinates here. So if I press G and move that around, you can see what's happening to the texture in this triangle here. So if I select all of these here, so I've selected both triangles here, and then if we scale in this window, so if we scale X by 2, let's turn off that there, which constrained the so if you have this ticked here, this will prevent the UV coordinates from going outside the texture. However, what I'm doing now is I'm going to scale the X coordinate by 2, and you'll see here that the image has repeated. If I do it again, you'll see we've quadrupled the detail of the texture. We've basically scaled the texture by 4 now on the X-axis. So if we do the same on the Y-axis here, So by playing around with texture coordinates, you can actually increase the detail without actually increasing the triangle amounts. And then to reset that, we can just project. Like if we go into UV unwrap faces and then project from view, in fact we'll do this to bounds. So this is an easy way to sort of do UV mapping here. So you can project from view. What that will do is where you position your camera. So if we position our camera here and then unwrap from bounds, you'll see it takes the shape that we have in the camera view here and then maps that to the actual texture here. This is a nice quick way to sort of unwrap complex shapes from models, which I'll get into more in a moment. So if I come back to this here, so as it's only a plane, we have 4 texture coordinates here. So another weird thing with the OBJ format is this is the X UV coordinate. This is the Y UV coordinate. In the OBJ file format, the Y UV coordinate is flipped or inverted. So 0 is actually 1 and 1 is actually 0. And then anything with a VN is a normal coordinate. And in this case, because it's a flat plane, there is only one of them. And it's basically reused. It's the same for each corner. So what actually happens in here is the only details which are recorded for the model are unique vertex, texture coordinates, and normals. And then anything with an F basically constructs a face or a triangle, if you like. As we triangulate everything here, each line should just have 3 groups, as these basically are, this is basically a textured vertex. This is what this applies to. So the first number here refers to a vertex position here. The second number here refers to one of the texture coordinates, and the final number here refers to a vertex normal. As there is only one vertex normal here, this end value will always be 1 in this OBJ file here. And then you'll see that the number ranges go from 1 to the end number here. So in this case, it'll always be 1 to 4 for the positions, and 1 to 4 for the UV coordinates or texture coordinates. So this is the file we'll be exporting all of our models in, and I have a tool which basically loads this file here and then converts all of these details into a unsigned short, which is in a format called fixed point, which I will now describe. So as a quick reminder here, obviously all the 3D models are made of triangles, as we've seen, as I've shown just now. These are known as polygons. Obviously this is the correct 3D position space, although Blender obviously uses a different 3D coordinate space. And these are obviously the correct angles. In Blender, the only sort of angle which is correct is the X rotation. So if you rotate the Z axis of anything in Blender, it's actually the Y axis when you export it, and the Y axis is actually the Z axis when you export it, just to make things even more confusing for you. And then, as I've said before, when you design a model, you're designing it in local space, which is why when we sort of create things, you try and keep them to as small as possible. Ideally, you want one of these axis or dimensions to be 1. Obviously, in this case, it's just a plane. But when we are working with larger models here, if I position us in front of the cow here, you'll see the dimensions of the cow. So the height of the cow is actually 1. Sometimes when you're sort of formatting these, it's best to add like a reference shape. So the size of this plane here is obviously 1. So if we move our cow over the plane here, then you can sort of scale it to fit inside. And then you know that when you sort of export it, what sort of size you need to sort of scale it to match your scene's scale. In this case, the cow is obviously a lot smaller than the other models. So really what we should have done in the actual scene is to reduce the scaling of the cow, or rather reduce the scaling of the Gumbas, monkeys and shy guys, as they are quite a bit bigger, although I have sort of scaled them back. One thing to note with some of these models is you may need to sort of play around with the size of them. If you import them onto the Wii and they appear to be missing triangles, it could be because there's a lot of detail on the model, and the triangles could be being missed when they are converted to the fixed point format which we are using. And obviously this bit here, obviously when you convert an image from pixels in 3D, they are converted into texels, which is always between 0 and 1. As I've described in the previous videos, which is probably a requisite for you to understand what's actually going on here. So this here is basically what I've just said about the Wavefront OBJ file format. So let's talk about the fixed point format, which I will now give you a quick view of what we sort of have. Let's find something simpler. There we go. So we have a floor plane here. So what we are looking at here is a plane which has been converted from the OBJ format of floats to the fixed point format that we are working with. So it says here, so this is a normal short here, and this is an unsigned short here. So what we have here is these are indices. They basically describe the order to pick a position, a texture coordinate, and a normal. So 3 of these numbers are the position, 2 of these are the texture coordinate, and 3 of these are the normal. So as you can see, this is actually quite compressed compared to what we looked at just now. Is it going to bring it up? No, it's not. Okay. So if I come back here, I'll quickly explain the this fixed point, the way that fixed point actually works. So before computers had floats, the way that they decided to do things was to emulate floating point or fractional numbers. So if you had like an unsigned char or U8, then you obviously have 8 bits. So if you want to use, if you want to turn this into like a floating point number, what you can do is you can split the bits. So you can say half of these will represent the whole number and half of these will represent a fraction. So anything in the upper 4 bits here will be a whole number. So in this case, this will give you a number between 0 and 15. And then these numbers here would represent 4 decimal places. So the first one there, that would be 0.5. The second one would be 0.25. The third one would be 0.125. And then the third one would be 0.0125, I think. It basically, what you're actually doing here is you're dividing by 2 each time. So this is the top one there is basically 1 divided by 2, and then 1 divided by 4, and then 1 divided by 8, and then 1 divided by 16. This is probably wrong here. That's probably it's 0.6125. So depending on how much detail you actually need depends on which sort of type or which whole number type you need. So if you needed more decimal places, then you might want to upgrade to an unsigned short, which would give you 16 bits to play with. However, if you want to have positive and negative numbers, then what you have to do is you have to sacrifice another bit. So now what we have is a fixed point format, which is 1.3.4, which can fit inside of a char. So what we have here is we have 1 bit that represents a positive or a negative indicator. So if this is set, then this would be a negative number. If this is clear, then it would be a positive number. However, this now only gives us a number between 0 and 7 on the whole number part. and this only gives us a fraction of like 1/8. So by increasing the data type here, we can obviously increase the precision of fractions that we can have and the whole numbers. And then if we need us to represent both positive and negative, then we also have to sacrifice a bit at the start here, or the highest bit, to represent that. That's basically fixed point numbers. Most of the time it's easy to split them in half, because then to convert, you can literally just take your number and then shift it by 4 to convert back. Or rather, if you wanted to, say you add the number 3.0, then you would just shift it by 4 to convert it to the fixed point format, and then you would just divide it by 4 to bring it back to a unsigned char. If you don't understand that, then it doesn't really matter, because obviously I'll be providing the code to do all that here anyway. This is just for info. So there's a number of different fixed point formats that the DS was using. They had one fixed point format for the texture coordinate, another for the normal coordinates, and another for the position coordinates. And obviously it changes because of the values which each number type kind of depends on. So the one that I picked was the one that was common to all of them, which is the texture coordinate here, which is 4.12 or 1.3.12. So we have 12 decimal places. However, this only gives us a whole number between 0 and 7. So the size of your models need to be between -7 and +7. That's the restriction that this puts on you. So that's the format there. And then this is kind of what it looks like afterwards. You end up with an array of shorts which represents the floating point numbers, and then this is basically the order to pick the textured vertex from here. Basically this is a textured vertex here. These 3 are positions, these 2 are UV coordinates, and these 3 are normals here. Basically 0x1 is 1, 0. So wherever you see 1, 0 here is this here, and then half of that, this here is I think this is 0.25. But it doesn't matter, but you can't see that anyway. So one of the things that we have to sort of handle all of these models is the display list manager, and then this basically handles the models for us. We basically add the arrays to this function here, and then this basically creates a new display list on the Wii. So if you're not familiar what display lists are, basically what happened on OpenGL is in immediate mode when you draw models. So on the previous videos we were using immediate mode to do graphics on the Wii. So if I quickly open up code from the previous video here, so as you can see here, we're basically using exactly the same again. We have the a position, our texture coordinates and our normals, and then to draw those we were using immediate mode, which is this here, where you basically say GX begin, you then pass in the data type and you say how many triangles you're basically going to, or how many vertex you are actually going to draw, or faces rather, and then you tell GX the individual parts here. Now in the background what's actually happening is GX is converting all of this into a format that it can use. So it could be that it's actually creating like a display list in the background. What display list basically is you basically record this here once and then you store it in an array, but what you're actually storing is a compressed format from this, which GX uses itself. So you basically record once, GX will then create a compressed list, and then you basically just replay that list every time you want to draw the model, and it's a highly optimized, fast way of drawing 3D models. That's kind of how it works with OpenGL as well. So that was that's immediate mode there. Obviously we will be using display lists. And this is basically what it's actually doing there. So as you can see, this command here is basically providing a position, a normal, and a texture coordinate, just like we were before, except we are in a list here. So you'll see at the start we call GX begin triangles and GX end, just like we did previously. However, there's a few more steps that we need to do to set up a display list. Unlike OpenGL, which creates an array for you in the background and it handles the array automatically, GX doesn't do that. So what you need to do is you need to create an array of unsigned integers basically. So what I have here is the array list structure here, and this will basically create an array list for us where we can just add new U32s to it automatically as we go, and that will handle creating the array for the model data for us. So to create a new array list, all we do is we pass the data from the model here, just pass the two arrays, and then we need to sort of work out the size. So there is actually a few things we need to sort of bear in mind. So all of these commands, they take up an amount of bytes in the array as well. So as you can see here, gxbegin, this command actually takes 3 bytes. Every time you call gxPosition32, that will use 12 bytes. gxNormal32 uses 12 bytes. The gxTextureCoordinate command uses 8. And gxEnd has no cost. So these things here, these were all found from, there's one DevKit Pro example, if I can find it for you here, which is where I found this out from. I think it's one of these Nihi lesson ones here. See if I can find it. No, it doesn't matter. It's from one of these anyway. This is where I got it from. One of these examples uses display lists. As I knew what a display list was before actually going through the example, I recognized instantly the use for it here. So this function here, this will actually do all the calculation for you. It works out how many bytes to create an array to contain everything. And then this command here, you need an array which is correctly aligned as well. So the bytes inside need to be aligned to 4 bytes. And then we basically call this command here to create an array list for us. Once we've set up the underlining array which will hold the data, we then call gxBegin display list first, and then we basically go over, draw in the model. So what happens here is we convert each vertex from our array here back to a float, which is what this function here does. So the F16 fixed point format which I use is basically a short, as you can see here. And then there's 2 functions which I use. One converts a float to an F16 or fixed 16, and then this other command here basically converts the model data here back to a float. So this is how it sort of does that here. So it basically takes the number and then divides it by 1 to the power of 12. So it's just shifting everything across basically, like. And then in here we need to convert back the data here. So the first number in this array is always how many textured vertex are actually present, and then each textured vertex is then presented in the vertex side of the array. The indices side of the array here, this basically just says in what order to grab one of these textured verts from in the array list, which is what it's doing here. So you'll see we have our indices array here and our vertex array here. we basically take the top number from each, which allows us to work out how big the array needs to be to hold things. And then using the indices number here, we basically times that by 8, as there are 8 of these numbers per each vertex here, and then we basically jump around depending on the indice value here, pick up the relevant vertex and then convert it to a float, and then we can use position, normal and texture coordinate to construct the model again. And that's basically it for converting the model to a display list that we can use. And then to draw everything that's recorded in one of these array lists, you just call DL draw mesh with the array list ID, and then inside here we basically get a pointer to the vertex, and then pass that to the GX core display list function, which needs the size in bytes and the data converted to a U32 pointer, which is what this is doing here. And then this will then draw our models. It's pretty nice. So if you go in the draw model command now, what you'll see is, just like before, we set up the position, and then all you do is you call DL draw mesh, and that's it. Nice and clean. And then to use your models, you now need to sort of keep a list of the mesh ID, which is what I'm doing here, and then you basically create arrays of all your models that you're using. And if I come into the baddie manager here, this is all the stuff needed to draw them, basically. Just like we were doing before in the previous videos. So everything is everything kind of just fits in now. And now going forward, you will be able to use actual models rather than cubes or flat sprites. So now we will come to the next part, which is how we can get models. So your options are, you can either create your own model in Blender, or one thing that I like to do is to have references, as in if you were sort of drawing a scene, then you would be at the location, and then you would sort of have a reference to use to draw that scene. Same sort of applies with 3D models. It's nice to sort of be able to view models which were actually used on that system, so you can get an idea of the amount of detail that you should be using or shouldn't be using. So a good site for graphics is, if you type in Spriter's resource, you'll see here it has a sister site here, which is the models resource. And if we go to the GameCube now, and then navigate to Mario Party, which is what we're doing here. So we will now look to add a new character. So let's see, who shall we pick? So let's see. Let's go for Sailor Cooper. Looks quite amusing. So I've no idea what format this is actually going to be in. This is something to bear in mind as well. So one thing you can do with these is obviously use them as sort of references for your own graphics. So downloading them is just one part. So where are we? So the other ones were from Mario Party 4. Where did it just put that? Did I put it in there? No. There we go. Okay, so thankfully, so there's two 3D formats in here. There's the OBJ version. I'm not sure what format that is. I know what these formats are. This is Autodesk, and this is Collada. So these are some formats you may be presented with when you download these models. If you get one of these, then there's going to be some additional work that you'll need to do to convert it. We are going to need to do some additional work here, as this is split into a number of different textures here. So with the if you have anything that uses multiple textures, which is the case with this one, then we're going to be best off compiling them into a single image. This is fine. This is fine here. This will be educational for you then, better than if I'd picked one which was already nicely formatted. So let's go into Blender here, and then we'll want to import our model here. So what I'll do is I'll show you, you might not have these automatically set up. So what you would need to do is go into Edit, Preferences, and then you would need to go into Add-ons, and then there are some additional things here. Is it in here? Yeah, here you go. Import, Export, FBX format. There's also one for DXF here. Another format there, PC2. Another format there, BVH. So the formats I've selected here, OBJ format there, GLTF, although I won't be, we shouldn't be seeing any of those. And then there's probably the FBX and DAE in here somewhere. So you would tick these to add these to import and export. So we'll now, what I'll do is I'll show you what the Collada model will look like first. Okay, that didn't work. So we've got an error here. Okay, let's try and import the FBX format then. Okay, that one's worked. So one of the things that happens if you export this as in fact, we won't export it in here at this very time. Let's get out of this, because this will pollute the whole scene with and then we'll open this up again. I'll explain that in a moment. Basically, when you import these models, they will basically so the OBJ format, it doesn't have any animation in there at all. They are just static models, whereas DAE and FBX, they sometimes have what's called bones, which is how the models are basically animated. They have like a virtual skeleton which is mapped to the model triangles. And then there's also rotations, scales and translations applied to the bones. Obviously we won't be using any of that, so we basically will need to only export things that we intend to use. So here's our model here. What I would recommend you do is get rid of the skeleton there. So you see there the model's rigged. Basically what that means is the skeleton had rotations and everything applied to it. So we are going to export this as an OBJ now. We'll then import it into the other actors file. We'll also scale it as well. As you see here, the dimensions for it are massive. Thankfully the origin is still fine, so what we need to do is rotate that on the x-axis by 90 degrees, and if we press 1 on the numpad, that will come to the front view here, and then if we press Ctrl and A and apply rotation, this then zeroes the rotation here. Now what we need to do is to scale this model back by a considerable amount here. So let's scale him down. So the sizes, let's zoom in on him again. Press the dot key on the numpad there to automatically zoom in on the selected model there. So we will scale him right down. In fact, let's keep the Y as 1. Now what we need to do is we need this to be reset to the starting scale. So if you press Ctrl and A and scale, that's now 1 there. Now what we can do is export this as an OBJ format here. And then select selection only. And then we'll also triangulate faces and keep vertex order. So what I will do is I will save this one here. Save that as Cooper start. So here we are back in the actors scene here. So let's import. So another thing to do when you import, make sure first that you set your origin to, or rather you snap the cursor to the world origin, which should be 0, 0, 0. If you go into Tool here and then View, you can see the cursor position here. And then now if we import, File, Import OBJ, let's take our Cooper here. There we go. And the reason why he's black is because it can't find any of the images for his texture. So we're going to have to fix that in a moment. So first what we're going to do is we need to fix the rotation. Okay, it's rotated with 0 there. So what we're going to have to do now is you'll see here there's a number of different textures here. So what we might have to do is to split it down. So this one here will take us into untextured here. So he has a number of textures associated with him. So we need to basically create like a texture which will contain all of these here. So what we will do is we will resize the canvas to 256 by 256, which should be large enough. Hopefully there's no UV scaling in here, otherwise that will make it more complicated. So all I'm doing is, where is the right one? Here we go. So I think we can actually cut the size down actually, so we can go and split that in half actually. There we go. So that should be everything contained in our new texture now. So we will remove all of these, and now we need to add a new texture. So now what we need to do is we need to go into edit mode here, and we might need to split things up a bit, not sure yet. So a quick way here is to select one triangle, and then if you press L, that should select everything that's linked to that face. Now if we go into UV editing here, and if we scale this back on the x-axis, yeah, I think that's right there. So now what we'll do is we'll sort out the eyes. So what I've done there is I've selected both of them. If I go into flat shading here, you can see I've selected both of the eyes here. So the texture coordinates were laid out as if it was for the singular images. So what we need to do is to scale them down and move them over onto the right part of the texture for each of these faces here. So if we scale that there, and we'll zoom in. So what I'm actually doing here is, if you see in here, this is scaling things to corner. What that means is each vertex here is being mapped to a corner of a pixel here. So you can individually map these vertex to align to either a corner of a pixel or center, or you can disable it if you don't want to do that. Sometimes you might have to play around with this where it will look fine in Blender, but then when you actually load it in on the console itself, it won't look right. So let's try and figure out where these other parts should be mapped to. So we'll start with the arms. So we hold down Shift and L. So we've got both of the arms here. The question is, which model was this in? Or sorry, which texture? I think it was probably in here. So we'll just drop it in. I've no idea what that is there. Maybe that's the mouth or something. I think the arms look fine. So let's try. Let's try the hat now. No, it's not going to be. I think it might be the top one there. Okay, yep, I think that's right. So we've got his hat. Yeah, his hat looks right. Okay, what else do we have? Let's try his shell now. I think the shell might be this here. So all I'm doing here is I'm pressing S to scale and then X and Y. So if you press S and then press X, then you'll scale on the X axis there, and you just move your mouse around to reposition it. And if you press G and then X, that will just move on the X coordinate there. I'm thinking that's the bottom of the trainer. Is this the scale that on the X again? Is maybe we're doing too much here. Not actually sure what the shell looks like. Is it that, or is it? It's got to be that, surely. Okay, I might have the shell wrong. I'm not too concerned. I'm guessing this here might be over here. Is it going to be up here? Or is this down here somewhere? kind of looks right there. Let's do the legs as well now. I'm guessing the legs are going to be on here somewhere as well, so we'll just do that. Is the cravat going to be here, do you think? Or there? As you can see, the UV texturing is sometimes can be like a jigsaw puzzle. I'll leave it there. I'm not really too concerned. As you can see, the core part of we'll get them looking roughly right there. Okay, this one here then is definitely over here. Let's move these individual parts across. Probably should have selected both of these at the same time, actually. So these now, what I'm doing is just scaling on the x-axis. And then just moving them over. Right, I think that's good enough. There we go. I'm not convinced with the shell though. I don't think the shell is right. However, I don't want to be spending all morning doing this on this video here. So here we go. We've basically converted our character to an OBJ. Now we've created a custom texture for him. He's positioned at 0, 0 here. So make sure if you move them around, for example, before you export them, make sure that they are at the origin. Otherwise, they will not look right when you import them, because they will have additional positioning applied to the data, which is obviously not what we want. So make sure, also make sure if you press the numpad, so 3 rotates you on the right orthographic view here. 1 is from the front view here, so you want to make sure that when you are viewing them from the front here, that they are facing towards you. There's no rotation on them. So if we hide that character there, click on the monkey, you can see there. So there's the size there. So we will actually add some additional scale in then. So let's hide him a minute. Let's have a look at the shy guy here. So for shy guy, X coordinate is 195. The width there you can see is 197. No, sorry, the width there is 267. So we'll take him up to roughly the same sort of size. That'll do. So we've scaled him up, so Control and A to scale. So let's see how he compares to the others. A bit taller, that's fine. Doesn't really matter there. So I'll save this file now. Now in fact, let's go into edit mode a minute. Just check to make sure everything's triangulated. Not too happy with those dots there, so we will fix those a moment. So we'll select all of that, go into UV editing. There we go, I think that's fixed that. Wonder what that there for. What that part there is. Maybe that's the shell rim or something. Okay, that's fixed that, which is good. So save that again. Now we'll export as Cooper. So when we export, make sure you have selection only, as we only want to export the model we are selecting. Triangulate faces and keep vertex order just in case you haven't triangulated the faces correctly. In fact, first off, before I do any more, let's go to vertex mode there. Press A to select all, and then we want to get rid of any mismatch vertexes. Happy days, that's removed too. So let's export him now that we've fixed that. Dropped everything that we had there, so we'll call him just Sailor Cooper this time. There we go, so that's that one there, so we can close that now. So what we need to do now is side-by-side folders. So we'll now use the OBJ conversion tool, which I will provide a link to. And then you'll have the source code for Linux as well as a Linux Mint file here. This does rely on the SDL library, so you might need to install that if you don't have it. And I also have the a Windows built version as well. So if you're on Windows, then you can just use the exe, which has the distributable SDL library with it as well. So that should be fine for you there. However, for Linux users, you'll have to have SDL present to be able to use this. So go into wherever you saved your models. So this is for me here. And then select your OBJ model and just drag and drop it across. And then, in fact, it's not that one there, it's this one here. And then get rid of the OBJ and then just save it. And then this will export it as a text file. And now what we need to do is go back to your program here. So we'll open our graphic defines here. We will add a new reference mesh ID. Now what we need is two arrays for our model. And then one will be _v, the other will be _i, and that will be U16. Then create a new file, a source file, make sure it's C, and then go to source, and then I'll just call it objcooper.c. Then we need to include the graphics defines, paste in our two arrays, then format these, ready to copy and paste our Cooper data in. Then navigate to where you downloaded your model. So quite a big model, this one. So we'll select the top array first, copy and paste that in, then copy and paste in the indices array, so don't need that anymore. So now what we need is we need to add the new image in. So navigate to the project, go to assets, and then what we need now is to add the texture to our project. Where is it? There we go. Paste that into our list of textures. Now what we need is we need to add this to our texture IDs. Now we need to get the image converter to find our converted texture. So make sure the name here basically matches this here. except you don't have .png, you have _png here. And then save this. Now we need to side by side these because we then need to add the texture to main here. So we'll load the image, which is, let's just copy this name here. Don't think there's any UV repeating, could be wrong. So we've added our texture there. Let's add our new mesh. So that's added there. Now we need to let's see. We're going to need to update the body manager here. So there's nothing in it. Here we go. There we go. That should allow the spawn function here. So there's a spawn function here. What it basically does is there is, if I come back to pictures a moment, we have a mock-up level here. Why is it doing that? This is bugging out for some reason. So the green pixels represent trees. The why are you doing that? There we go. So the pink tiles are basically just spaces that represent walls. There's two types of walls. There is the horizontal ones, which are represented by the cyan pixel there. The dark red represents the vertical walls. The pink one here represents the, or rather the magenta one represents the enemy spawning positions. The yellow is not used. So I'll include this map here as well. Obviously you can play around and create like a custom scene for your own version of this demo. So this is the basically the mock-up level which this is using. You could obviously change this, and then using the DS to tiles converter for your level, or just manually update the numbers. So this is where it's getting the scene data from. And there's also like a spawn position for the enemies, which it's getting from the level manager. And what it's using is 2D rectangles for their collision area. And then what it's doing first is there is a function in here for the body manager where you pass in the ID of the baddie to check against, or -1 if it's not a spawned baddie yet, or a different actor which isn't a baddie. And then this returns true or false if this collision rectangle overlaps one of the baddie collision rectangles. So you'll see here the mesh ID chooses a random number between 0 and the maximum baddie types here. So all we need to do is add Cooper in here although we don't have a sound effect for his spawning. We'll just give him Shy Guy sound instead. No, Cooper sound instead. Gumba, sorry. And then we just patch in the texture for him. And that should be it. Hopefully there'll be no issues here. Right, let's try and spawn one. Come on. Ah, there we go. There we go. There's our new character. Can we get any more? So you can only get one to spawn if they are not blocking the spawn point, as they're all bouncing into each other. Let's try and run that again, see if we can get more of them to spawn. Okay, yeah, looks okay. Happy days. So that's pretty much all I want to go through in this video, really. By all means, have a look through the baddie manager code here. It's outside of the scope of the video to go into any more detail really on this. The main thing here was to show you how you can create models yourself or import models to test and preview. So by all means, have a look what's actually going on here. The code for the baddies is kind of straightforward. There's nothing magic here. All what's happening is they have like a collision rectangle centered on their origin, and then when they spawn, there's a random sort of direction applied to them. The challenge I sort of had was trying to get them to go in the right direction. There's like another thing I was doing here to sort of play around with that beforehand, where I was manually moving them, as in updating their X and Y and Z separately. I'll get rid of this here, I don't think, so that it doesn't sort of confuse anybody. So that's it for this video. In the next video, hopefully I will actually have a 3D game. I'm probably going to look at creating maybe with a third-person camera, I'm thinking maybe a sort of simulate driving or something. Let me know if you've got any other sort of preferences, and maybe I'll implement that if it's with me before I sort of start on that in the next couple of weeks. So that's it for this video. I will catch you in the next one. If you've got any comments or questions, leave them below and I'll get back to you when I check up on the channel next. Thanks for watching.